Welcome back. Today we're going to be doing some more advanced examples of greatest common factor, one of them being finding the GCF greatest common factor of two different numbers, and then the next of finding the greatest common factor of three different numbers. So basically, as a review, the greatest common factor is the largest number that evenly divides two or more numbers without a remainder. And for more complex examples like these, we're going to be using factor trees. For simple examples, we could simply just list out all the factors of one number and all the factors of another, and then find which number is the largest and is on both lists. However, that might not be the most realistic method if we have really large numbers. And so I'm going to go through an alternate method for doing this. These numbers, actually, I would say we could probably go either way, but I will be doing the more advanced method in this example. So for this method, what we need to do is we need to find the factor trees of 18 and 27. I do have a whole video on factor trees and prime factorization if you're interested in that. But the short version is, in order to draw the prime factorization, we start with the initial number. So we'll start with 18 for the first factor tree. And then we need to find two numbers other than 1 that multiply to 18. And these can be any two numbers, as long as 1 is not included. So I'm going to go with 2 and 9. Now, any numbers out of 2 and 9 that are prime, meaning that their only factors are 1 and itself, would be circled at this point. So I'm going to circle 2 because 2 cannot be broken down into any further factors because it's prime. However, 9 is the same as 3 times 3. So for 9, I'm going to put 3 and 3. And 3 is prime, so I'll circle those 3's. So therefore, 18 can essentially just be written as 2 times 3 times 3, or 2 times 3 squared. Now, what about 27? Well, 27 is equal to 9 times 3, and 3 is prime. 9 is equal to 3 times 3, and those 3's are prime as well. So therefore, 27 is equal to 3 times 3 times 3, or 3 cubed. So to find the greatest common factor, I need to circle any factors that these have in common, and also the number of times they occur is needed to be taken into account as well. So 2 times 3 squared is the same as 2 times 3 times 3. 3 cubed is equal to 3 times 3 times 3. So therefore, in terms of what's in common, in terms of our prime factors, both of these have two 3's. So I'm going to circle those two 3's. And that tells me that the greatest common factor here is 3 times 3, which is 9. Notice I did not include the 2 or the third 3 because these are not prime factors that both of the numbers have in common. We need to only use the numbers that the prime factors have in common. And also the multiplicity as well, the number of times they occur also needs to be taken into account as well. So that's the way this method works. Now I'll do another example, but this time we want to find the greatest common factor of all three of these things. And some of the numbers are like 120 especially is a bit larger, so writing out all the factors may take us a while. So let's start with 48. What times what is 48? Well, one answer is 12 times 4 is 48, but again, you can start with something different and your prime factors at the end will still be the same. 4 can be broken down into 2 times 2, which both of those are prime. 12 is 6 times 2, so the 2 there is prime, the 6 is not. And 6 is the same as 2 times 3. And so therefore 48 is equal to 2 to the power of 4 times 3. Because notice that there are 1, 2, 3 4's, and then there's 1, 3. Then let's do the same thing for 72. So for 72, 9 times 8 is 72. For 9, 3 times 3 is 9. And for 8, 2 times 4 is 8. And then for 4, 2 times 2 is 4. So therefore, the answer is 2 cubed, because there's 2 3 times. So 72 is equal to 2 cubed. And then times 3 squared, because 3 appears twice. All right, now the next one is 120. So 120 is 12 times 10. 12 is 2 times 6. And 6 is 3 times 2. 10 is 5 times 2. And all those circled values are prime. So we have 2 cubed once again. We also have times just 1 3 right there, and then times 1 5. So now that we've done all our factor trees, I'm actually going to erase the factor trees now, and we're going to just look at the results of our factor trees and what they have in common here. So in this particular case, we have 2 to the power 4 in the first one, 2 to the power 3, and 2 to the power 3. So the highest that we can do for all three of them would be 2 to the power of 3, right? So 2 cubed is the first part of this. And then in terms of threes, we have 1 3 here, 2 3s here, and 1 3 here. So since the most or the least number, or I should say, sorry, the most number, the highest number we have that is in all three of them would be just 1 3. We're going to put 1 3 because 1 3 is the most that all of them have in common. Only the second one of 72 has 3 multiplied twice. And then the times 5 over here, it's only in 120. It's not a prime factor in the other two, so it wouldn't be included at all. So that means the GCF is 2 cubed times 3, whatever that is. Now 2 cubed is 2 times 2 times 2, which is 8. So therefore the GCF is 8 times 3, which is 24. And so therefore our answer is that the greatest common factor, the GCF of all three of these, is 24. Now, as always, feel free to put any questions you might have in the comment section, and we'll see you for the next one.